Hello everyone, this is Jyotsna. Welcome back to my YouTube channel. In this tutorial, we will see one of the design pattern. So first start with what is design patterns and the different types of design patterns. So design patterns are reusable solution to common problems that arises during the software design and development. So these patterns provide general solution guidelines and templates to help developers solve recurring design problems in their software application. There are main three types of GOF design pattern: creational, structural, and behavioral. So these patterns again divides into sub patterns. So creational design patterns deals with the process of object creation, while structural design patterns deals with the composition of object structure, and behavioral design patterns deals with the process of communication, relationship, and responsibilities between the object. So let's start with creational design pattern. So there are five main types here: singleton, factory, method, abstract factory, builder, and prototype. So today we will see the builder design pattern. So let's go over the definition of builder design pattern. As I said, it is a type of creational design pattern and it is used in software design to construct complex objects step by step. This pattern separates the construction of complex objects from its representation, allowing the same construction process to create a different representation. So why we use it and how we use it, we will see next. So when to use this builder design pattern? So there are many different scenarios where we can use this pattern. So this is useful in some scenarios where we need to create complex objects that may have several parts, configurations, or optional components. For example, when an object has multiple parts or attributes. So when we have that, one of the example is building computer objects, right? So we can build computer object with the various components, like computer have CPU, RAM, GPU, storage, etc. So where the combination of components varies depend on the use cases, like computer can have of different types: gaming computer or office use computer. So based on that we can have different types of computer, and the components which are used for creating those computers might be different. So if the object you are constructing has multiple parts or attributes that may change in different combinations, the builder pattern helps manage this complexity. So for this, the builder separates the construction of objects from its representation, making it easier to handle. So another use is like when you need to create a different variants of an objects. So if you need to create a different types of variations of same objects, the builder pattern allows you to easily switch between different configuration without changing the object itself. So one of the example is a car object. So that can be built for different purposes, like car can be of, for sport car, family car, electric car, where the configuration like engine type, color, seats of the car vary, but the structure remains the same. So this comes under this when you need to create a different variants of an object. Now when one of the other use is when an object's construction requires multiple steps. So whenever you want to create an object, that construction of that object requires multiple steps. So if the creation of an object involves several steps or a sequence of method that need to be called in a specific order, the builder pattern helps keeps this logic organized. We use director class for that. So we can see that later also. The director class can control the construction process, ensuring that each step is done in the correct and organized sequence. So another use is when you need to handle optional parameters. Now, if the objects you are creating has many optional parameters, the builder pattern makes it easier to set these parameters, avoiding long constructors with many arguments. So one of the example is house object. So when we want to build a house, we need to create a house object. with optional components, like we want garage or pool or garden. These are optional components while creating house objects. So you can choose which component to include in the final object using a builder. So that is one of the use we can do using the builder design pattern. The next is when you want to separate the construction logic from the product representation. So the builder pattern separates the logic for constructing the objects from its object itself. So this makes it easier to modify or extend the construction process without changing the object representation. It also makes the construction code more flexible, as it can evolve without affecting other parts of the system. And one of the example is the documents with multiple parts. Means, for example, we have a document where we have the title, paragraphs, tables in the documents. Now we can separate the logic of adding those parts from the document structure, right? The next is when you need to ensure consistency in object creation. Whenever we want to ensure the consistency in object creation, we can use the builder design pattern. So how we do that? So builder design pattern can enforce that certain required steps are followed and certain properties are set when constructing the object. And this is particularly useful when dealing with the complex objects that should be consistent in how they are built. And one of the example for this is uh, a pizza object, right? When you want to build or create a pizza object with mandatory components, like we want to top and sauce and optional components like toppings, the builder ensures that all the mandatory components are always set. Next is when you want to use the same construction process for different representations. So if you need to build a different representations um, of the same product, like for example house or car, the builder pattern allows the same construction process to be reused for the different variations while enabling the flexibility to customize the details. So one of the example, as I said previously, house example, where we have the different styles of house like modern or traditional house. So while keeping the core building process the same, like foundation, wall, roof, windows, keeping those same. So we are constructing the house. So last one is when you want to use the method chaining. So the builder pattern often uses method chaining. So how here method returns the builder itself, allowing you to set up various properties in a fluent and readable way. This enhances the usability and clarity of the code. And one of the example for this is meal builder, where you can chain methods to set different aspects of the meal. So these are some of the uh, ways, or we can say where we can use the builder design pattern. Let's start with the some of the applications where we actually use the builder design pattern. So building complex UI elements like graphical user interface frameworks, we use the builder design patterns. Then document generation like report files or web pages, and construction of complex SQL queries, we can use the builder design pattern. Also configuring and constructing network requests like HTTP request, and creating complex data structure tree graphs, constructing vehicles or machines with different configuration. Again, game developments where we have different characters, levels or item creation, we can use the builder design pattern. Also building graphical shapes or objects, SVG or geometric shapes, and managing complex APIs and SDKs, building customizable reports or dashboards, and building e-commerce shopping cart. So these are some of the examples, or we can say applications, where we can use the builder design pattern. Okay, let's start with the problem statement. So I wanted to explain why actually we use the build and design pattern. So we have seen where we can use the different application, but try and understand what exactly be the problem where we can use the builder design pattern. So let's consider we are building a house, right? So now let's think that how we can create a house object. So to build a simple house, we need four walls, floor, door, pair of windows, and roof. So with these created objects, we can build an house. Now that will be one simple house, right? But these are the basic needs only. But there are some house which we want to create with garage, or somebody want to create a house with fancy statues, or somebody want swimming pool in their house, somebody want the garden in their house. So um, it's based on like who wants to create what type of house. There are many different possibilities of creating the house object. Now here there are two approaches we can build a house. One is we have one base house class, and we have different subclasses which will then implement that base class with all different combinations and parameters. But eventually you will end up with considerable amount of or number of subclasses. Now any new parameter we will add, or we will require growing this hierarchy even more. Now there is another approach we can use, which is we can create one big constructor where we will have all the properties or parameters passed into that constructor for the base house class that controls the house object. Now, with this approach, we will eliminate the need of subclasses, but it creates the another problem. So, how it creates the another problem? Because we are using only one constructor, and for every house building, that all the parameters are not required. So, it will be like creating a constructor where we have the unused parameters, and that will be pretty ugly. So for instance, only a fraction of house has swimming pools. Not all house will have the garage or garden or swimming pool. So those parameters will be unused. So even if we have these two solutions, we cannot build the house properly, right? So what solution we can have here? The solution is using the builder design pattern. How? So the builder design pattern suggests that you extract the object construction code out of its own class and move it to a separate object called builder. So for house we can have the house builder, and that will have the different construction method. Like for wall we have build wall, for door we have build door, build windows, like that. So here the pattern organizes the object construction into set of steps like build wall, build door, etc. So where we create an object, you execute a series of steps to build an house object. The important part is that you don't need to call all the steps. You can call those steps that are necessary for producing a particular configuration of an object. Right. So some of the construction steps might require different implementation when you need to build the various representation of a product. Now here, for example, the walls of the cabin may be built with wood, but the castle walls may be built with the stone. So that time we have to have the um, wooden walls or stone walls. So in this case, you can create a several different builder classes that implements the same set of building steps, but in the different manner. Then you can use these builders in the construction process to produce a different kind of objects. So when we build our application with using a builder design pattern, there are main components which we use. These are the five main components. First one is a product. This is a complex object that the builder pattern is responsible for constructing. Now, for example, computer. We want to build a computer, then this will be our product. Now, what is builder? Second component. This is an interface or an abstract class that declares the construction steps for building a complex object like computer builder, because we are building this product computer. So name will be like something like computer builder. So this will be our interface or abstract class. Again, concrete builder. So now Computer builder might have different types like gaming computer on or a simple um, official use computer like that. So concrete builder will be the classes implements the this builder interface, providing specific implementation to the that particular builder. So implementation for building each part of the product. For example, we have to create a gaming computer. So we'll have the concrete builder as gaming computer builder, which will then implement to this builder interface. Again, we have another component, director. So here the responsibility of director is to manage the construction process of the complex object, and the name which we give it to director. So whatever the construction process, by using this builder uh, co- different methods from concrete builder, it uh, create the complex object which is our product. And then again, the fifth component is client, where we initiate the construction of the complex object. So creating a director component is not necessary, but if we use it, it's a good for the code management and like hiding the details and the showing whatever we need only in the client code. So these are the five main components in the builder design pattern. So let's see the generic class diagram here. So as I said, different components we have is product, concrete builder, which implements then builder interface. And then again, we have the directed class with construct method, which will construct our product here. And client will call this director object from here. So this is a very simple generic class diagram, how exactly our builder design pattern behave. Let's go through some use cases scenarios here. So where we can use the builder design pattern. Some examples I have given here. The first one is building a customizable meal or ordering system. So in the meal ordering system, customers can customize their meals by selecting different starters, main course, drinks, and dessert. So each component has multiple options, and some components are optional like sauce or toppings. So one of the use cases is a customer orders a meal by selecting options for each course, and the meal may have many combination like vegetarian meal or non-vegetarian meal. So based on that, our vegetarian meal will be one builder, concrete builder. Non-vegetarian meal will be our another concrete builder, like that. So builder pattern can help construct a complete meal order by adding optional components one by one. So this is one of the example we can build using the builder design pattern. Another example is building a complex web page layout like HTML. So web application allows user to create custom web pages where they can choose components such as header, footer, sidebar, content section, and multimedia elements like images or videos. So each section can have the different styles, and some sections are optional. So this use case means constructing a web page with a multiple optional sections with each of its own properties and content. So here the builder pattern allows users to construct a page in a modular way, adding components step by step without having to deal with the complex logic once or at all. The third one is building a customizable document like word processor. A word processor or document generation system allows user to create document by adding text, images, tables, and other elements in a specific order. Each section may have different formatting, and some sections are optional. So while constructing a document where the user can add sections, header, paragraph, images, or tables um, dynamically, the builder pattern here helps in assembling this section in readable, flexible, and maintainable way. So these are some of the use cases where we use the builder design pattern. Now there are some advantages as well as disadvantages of builder design pattern. Let's go through advantages first here. So separation of construction and representation. So this is main advantages of builder design pattern. Here we keep construction logic separate from the object itself. like making the code cleaner and more flexible. Also, using builder design pattern, we improve the readability of the code. So prevents long constructors with many parameters, allowing the method chaining and a fluent interface. Also, it provides the flexibility. How to allow dynamic addition of optional components and ensures objects are always in a valid state. It also supports immutability where it can be used to create immutable objects by ensuring all fields are set during construction. The one other advantages is it improves the testability. Like individual construction steps can be tested independently. So these are some of the advantages of the builder design pattern. So there are some disadvantages also while we use the builder design pattern, like increased number of classes, because we add the classes for all the uh, builder component. We add extra complexity by introducing builder classes, which can be overkill for simple objects. It also overhead for simple objects, like unnecessary for objects with few attributes, as if it introduces unnecessary complexity. So another disadvantages is maintenance complexity. So managing many builder classes for different products variations can become bothersome. Yeah, and performance overhead. So can introduce minor performance overhead due to step-by-step construction. So these are some of the disadvantages of builder classes. So we have seen what is builder class and where we use it, some advantages, disadvantages, and the problem statements for the builder class, right? So in our next video, we will implement one small example, how we can implement the builder design pattern. Yeah, so that is for this video. Thank you so much for watching.